a new application about the first law of thermodynamics. I hope you already saw my last video about the sign of the work done on the system in terms of the shape of the process, either a simple process or a cyclic process. Here, what we have exactly, we have a cyclic process, and find the net energy transferred to the system by heat during one complete cycle. Let me explain what I mean. First of all, the net energy transferred. So when I say transferred, it means I am talking about the heat. The heat. The heat of one complete cycle, it means we have Q, we have to calculate Q of the cycle. Okay? This is the first point. The second point, the energy transferred to the system. It means the system will take this energy. The system will absorb this energy. So Q must be positive. When the energy of the heat released from the system, it means Q must be negative. When the energy absorbed, so it must be positive. I will explain in details this point. Okay, in general, we talked about that before. When we have a clockwise cycle, as you see here, so the work done on the system must be negative. Okay, this is the first point. The second point, Q of the one complete cycle equals to minus the work done of one cycle. You have to memorize these points direct, and you can apply them directly. This is the second point. We said that the work is negative times negative, we have Q must be positive. Okay, Q must be positive. This is the second point. The third point, the work done equals to minus the area inside of the yellow area inside the cycle. Okay, so to calculate Q, we have to calculate the area. So we can have the work, and after we can have Q of the cycle. In this case, we go directly to calculate the area. If we have a right angle triangle, the area of this triangle equals to the adjacent sides. Let's say we have A and B. The area equals to A times B divided by 2. A, the length of A equals to 2, from 6 to 10. Excuse me, equals to 4, from 6 to 10. Or you can say directly, this distance equals to 10 minus 6. Okay, we get 4. So equals to 4 times B, the distance between C and B, it's between 2 and 8, equals to 6. Or we can say 8 minus 2 equals to 6. Be careful here. We have K Pascal. So we have 10 power 3. We can say directly equals to 6 times 10 power 3 divided by 2. 6 times 4 equals 24. Divided by 2, we get 12 times 10 power 3. This is the value of the area. So we can get directly Q. Okay, you can say directly Q equals to A. Okay, Q equals to minus A equals to minus 12 times 10 power 3, the unit of the work in joule. We can substitute this one by K. We can say minus 12 K joule. This is the work. And Q, which it must be positive, equals to minus omega minus the work. And we can say directly equals to A, okay, which is equal to 12 K joule. This is the answer of Q. And as you see, it is a positive value because it's the energy transferred to the system. Okay, this is the first point. The second part, what if the cycle is reversed? It means we pass from A to C to B to A. It means that we have anti-clockwise process. We saw that before in the last video. If we have anti-clockwise process, you have to memorize by heart directly the relation between the work and the area and the sign of each one. In the case of anti-clockwise, the work of the cycle must be what? Must be positive. Okay? So if we have the same area, we can say directly equals here we have negative value and here we have a positive value, so we get 12 K joule. Okay, in this case Q of the cycle equals to minus 12 kilojoule. Okay, this is the answer. I want to look, just you have to know 2 points, very important. In the case of clockwise, the work must be negative and the Q is positive. So the energy transferred to the system, okay, we can say it is Q hot, it's positive. In the case of clockwise cycle, the work done on the gas must be positive, anti-clockwise, must be positive, and Q of the cycle must be negative. What I mean by negative, it means this energy released by the system, released. We can say it's Q cold. We go to the next application with a new video. This is a new problem. Just I want to combine this one with the last one because we use the same figure, the same process, and it's very important problem to understand well the sign of each term, the work, the heat, and the internal energy. For this, what we have exactly, if Q is negative for the process BC, Q BC is negative. Delta E is negative for CA. What are the sign of Q, the work, and the internal energy associated with each process? Let me before draw a simple table and we can fill and calculate the sign of each term. Okay, I do it quickly. 1, 2, 3. Okay, it's not perfect table. It's not bad. First of all, we have AB. After we have BC, and the last one is CA. I calculate the first of all Q, W, and delta E. Okay. First of all, what we have exactly? We have BC. The sign of Q is negative. We have CA. The sign of delta E is negative. Perfect. Okay, now I have to complete the table. Let me start by BC because we have a given value, Q. I don't want to start by AB because I have nothing about AB. Okay. Let's write here the answer. Because if you want to fill the table, you have to justify your answer for each part. What about BC? BC, it's an isochoric process. You know, if we have V constant between B and C, constant, so we can say directly that the work done during this process equals to 0, simply because it's the area under the curve. The area under BC equals to 0. It's a point. So WBC equals to 0. And remember that delta E of any cycle or for any process equals to Q plus the work. So we have to find the sign of delta E. We can write directly delta E of this process equals to Q plus W of which one? Of B, C. B, C. Perfect. And now W equals to 0. Delta E equals to Q. As Q is negative, so delta E must be negative. La is a very simple justification. We can say delta E is negative. So delta E is negative. This is about BC. Let's go to CA. CA. Okay. How you can solve this issue about the sign of the work and the sign of Q? About Q, I don't know. But about W, let's say we have here, as you see, the volume decreases from C to A. And we saw before, if the volume decreases, we have compression. In this case, the work done must be positive, applied on the system. Positive. It must be positive. So this one is positive. So the second point is okay. What about Q? We can write the famous relation of CA. Okay, the work is positive. Ca. Delta E is negative. Okay. Okay, I want to change. We can put Q here. Let's say QCA equals what? Equals to delta E minus omega. Okay, we can write like this. Okay, delta E is negative. Delta E is negative. Omega, excuse me, the work is positive. Okay, this negative minus this one is negative, and the work is positive, and before we have minus times positive, we get a negative value. Okay, so we have this one negative and this one is negative, so QCA must be negative. Okay, this is the first point. We can solve it by another method. We can see that later. So QCA is negative. Let's go now to AB. What about AB? You know, AB, it's not, we don't have a specific process. We don't have isobaric. We don't neither isochoric. It's a linear, simple relation. So how can we start? By which value? I think, as you see here, AB, the volume increases from A to B. Okay, so let's say we have AB. From A to B, the volume of A equals to 6, B equals to 10, so the volume increases. In this case, we can say the work done on the system between A and B must be negative directly. So this one is negative. This is the first point. The second point, delta E. If you think now, we have one hint. The total delta E of the cycle equals to 0. You know that, which is equal to the sum of each process of AB plus delta E BC plus delta E CA. Okay, look, the sum equals to 0. The sum, the total. Delta E, what we have exactly? Delta E BC is negative. Delta E CA is negative. To have 0 total delta E, so we must have a positive value of delta E AB. For example, if delta EBC equals to minus 5, delta ECA equals to minus 7, so delta EBC plus delta ECA equals to minus 12. Okay, so we must have a positive 12 of delta EAB to get a 0 value of delta E cycle. So we can say here delta E BC plus delta E CA, they have a negative value. So delta E and delta E of the cycle equals to 0. Conclusion, delta E AB must be positive. Okay. Okay, that's about delta E. Let's go to the last one, QAB. QAB. Here you have, as we like, we have many methods to find the sign of QAB. For the first, let's say we can solve it by talking about the total Q of the system. Okay, you know Q of the cycle equals to what? Equals to the sum of the total Q equal to QAB plus QBC plus QCA. The same for the work equal to the sum of the total work. And you know, a Q of the cycle, it can be positive or negative. Okay? It can be positive or negative. It depends the sign of the cycle, clockwise or anti-clockwise. Okay, let's say here we have a clockwise cycle. You know, in the case of clockwise cycle, the work of the cycle must be negative. Okay? And Q of this cycle equals to minus the work. So Q is positive of the cycle. We can say here Q of the cycle is positive. So here we can say directly, now I talk about the cycle, okay? This one must be positive. Okay. Q, B, C is negative. Q, C, A is negative. So this one or these two values are negative. To get a positive total heat, we must have a positive QAB. Okay, we can say the same resolution as delta E before. We can say here directly QBC plus QCA. These two values are negative. Okay, we can say Q of the cycle is positive. Conclusion, QAB must be positive. We can have another method to show that, to calculate the sign of Q. So this one is positive. When I say QAB is positive, it means during AB, the heat goes out of the system because it's a positive value. QAB is positive. Released by, gained by the system. No. When we have a positive value, it means it's into the system. QAB, this value is gained by the system. Okay. QBC is negative, here released by the system. And here also we have QCA is negative. It means the heat is released by the system, out of the system. QAB is positive. It means it's into the system, transferred into the system. Okay, it's a very important problem to find or to understand the physical meaning, the physical explication of each point about the sign of the work, the relation between the work and the volume increases, decreases. All these points are very important. I advise you to stop the video, understand each point, and if you have any question, do not hesitate to send me your question in a simple comment on our videos. Thank you.